Welcome, Earthlings. This is Puro314, broadcasting from Maine via the MCWA, MCWCAM. Gonna get that right eventually. Broadcasting platform located, as you know, in the Terran stratosphere. Welcome, reflected worldwide. Okay, so today's little stream is we'll get it started here in a second. It's a humble stream because I made a little math error. You guys made a little math error. It's an unfortunate event, but the nice thing about it is it can be detected and corrected. All right, now if you remember what was going on here was, I was going through force and math. I made another mistake I caught during the time, which was joules for newtons. But then I was calculating the distance. We ended up with this little formula here, right? And for distance. So if you have a force, you apply a force for a particular amount of time. And we left all these deltas off because basically if you leave the delta off, it's like you're starting from zero. So like if you say, when I said acceleration is velocity over time, that's true. But since it's really v1 minus v0, taking into account your initial velocity, but if you're starting from rest, then that v0 is zero, and you can, and the reason I'm doing that is because of the unit analysis that I'm trying to teach. Hey, if this goes on, I'll be happy to get into the point where you have, v, 1 comma 0 minus v 1 comma 1 plus the v and the 1 1, and and you have a lot of different velocities as the velocities are changing or there's multiple objects. But so we went through all of that. That's all fine. Those aren't mistakes. But when I use this formula here, um, we got here, I plugged in 500 newtons of force and 5 seconds over 1,000 kilograms of mass. That made that 25 seconds squared. Those cancel out. Oh, look. Look, you guys. Look. Oh. I wish one of my commenters would have caught this. That would be a good little thing. But 25, right? The seconds cross out. Oops. The variables, remember, I hate when this happens. That's why I didn't buy a Wacom, see? Stop. Oh wait, I found a way to do it. Yeah. No. This is ridiculous. Stop. There we go. So anyway, this guy right here, I've left that off. Are you kidding me? All right, so I forgot. This needs to go down there. I just put the 500 and I left the 25 off. So this is times 25. Now, the units, s squared, second squared, that's a unit. By the way, if anybody wonders what a scalar means, a scalar is a number that doesn't have units. So if you cancel out the s squared on the top and the s squared in the denominator of a fraction, and you end up with a number just 25 here, well, that's a scalar. And, that's sort of an important concept, but also, a little bit esoteric. So anyway, what happened is I left out this 25 times 500 number. So 500 times 25 equals 2500, and then 1000. And so I'm not going to do calculations ahead of time. That'd be point. I'd rather you see mistakes and stuff than figure it out all ahead of time and make it not real. This is about I've understood math and physics enough to use them and apply them for fun and profit. So you can make mistakes and fix mistakes, and I'd rather you see how it normally is rather than people prancing around on rehearsed mathematics. So please, I wish somebody would have caught this, but it doesn't matter. I'm not shaming you; it's my mistake. But that would have been cool. So if I want to get it right, I guess I could use a calculator too. Let's check that. So 500 times 25. 12. Oh yeah, oops, because see. Yeah, because I did that. I accidentally typoed a 1 there, and then when I read, typical math mistake, right? Like a plus and a minus sign getting wrong. You always have to check your calculations. Well, but that's why I found this one, and then I did again, and I checked. So this is how you get them right when you really need to get them right. But for a video, I wouldn't think, oh, I absolutely have to get it right. But I should. That's the whole point. That's the Hythloday principle. Get it right, right? So that's why I double check. I can't promise to get it right every time when I do it because I want to do it impromptu and show you, my process, which isn't perfect, and I'm not a professional mathematician teacher or anything like that. So I want to get it right, but it's going to be an iterative process, right? So let's check our work. Anyway, it's 12 of 500. So basically, yeah. So let me just fix this. So this guy down here equals 12,500 meters over 1,000. And so that means that down here in the answer space, we so 12,500 meters divided by 1,000 is going to be 1.25 meters. So that's the answer, you guys. Thanks for sticking with me. Glad I could catch that. Really, really proud to be presenting physics and math in a simple way, in this cross product way, right? Like, if V equals D over T, right, then that means that D equals V times T, right? So that means we have a velocity time, just like we have a kilogram meter or whatever. We have a velocity second, right? A mile per hour second, right? And that means that the V is across a time, right? That's what that means, that it's across that time, that it's crossing this time. So it's crossing a time from one time to another, and the velocity and the time could be said to be crossing the velocity. So if you have that velocity crossing that time, what is it? It's a distance, right? And so that's how we can calculate, given a force, a mass, we could acceleration, we could calculate a distance. Given the distance and the time, you could calculate the force, and so on and so forth. And what's really fun is the way multiplication and division, addition and subtraction to a lesser degree, but especially multiplication and division, how those combine time space and mass, mass times space, the three measurable things, mass, time, and space, how they get combined and related, right? So that the time is squared because on the equation, the time is on one side, distance is on the other. The fact that the time gets squared doesn't square time. That's not the number that comes out bigger. If you have 1,000 seconds, you've dropped this 1 kilogram weight for 1,000 seconds. You don't end up with 1,000 seconds squared, right? 1,000,000 seconds. No, it's 1,000 seconds. You end up, the million part ends up going over in the distance because you dropped the thing for so long of a time that the distance got squared. The end result, because when a variable is squared, that's going into some other calculation. The isolated variable that's on the left is the thing getting calculated. When you have time squared on the other side, then it's the distance that ends up being bigger, right? The time is still 1,000 seconds. That's what you plug in, and then you square that to get the distance. So these kinds of things, I promise they're really simple and natural, but it's like air is invisible. So what's it all about? It makes it more complicated. The fact that something is so ever present, the fact that something seems so obvious. Like in a more advanced class in college, we had to prove A equals A. Like that's one of the things you would have to prove. So you have a system of logical rules, and you're like, is it a mathematics? Well, for it to count as a mathematics, induction has to work, and the law of identity. The law of identity is A equals A, so you have to prove A equals A. And, I did learn what they were going on about to a certain degree. It was probably my most, weirdest course, because it's like, don't we just assume A equals A? Don't we start? And it's like, well, we kind of start with that, but if you've got some of the other rules and you want to check, does the law of identity still work? And yet it's still kind of difficult. Like, what do you mean? Proving A equals A? But so you have to break down into things like that and prove relationships between things. Now, in a mathematics, the interesting thing is that since we have these three measurable quantities, when you make these multiplication and division relationships that mean either that you're going cross, you're taking the kilogram across a meter, and that's a kilogram meter, or you're moving it over a certain period of time, so it's per. You could have a kilogram per meter. Why? Maybe I have a pipe, and it weighs a kilogram per meter of the pipe. So that's per. That's different than cross, right? And so, and those are really the only two relationships. The plus and minus are offsets, right? That you start in a different origin point. But that's more arbitrary because your starting point, what counts as a zero velocity, depends when you start measuring, right? Like I'm going on the earth at all this speed, but measured relative to this room and this house, the way I actually measure in my ordinary life, I'm zero. So you can kind of set your zero depending where you want to start counting from. But with multiply and divide, that's different. You're distorting or warping things because it's a per or an across relationship. So thank you very much. And I don't know. I'm thinking about, because again, Hyphenate principle. I'm old enough. I was like 30 something when 32 or something when. So I remember the towers in a way that as time passes, there's more and more people that were kids, and so it's distorted through childhood, or maybe undistorted, right? But whatever, it's through that lens. And then of course more and more people, you could have a whole 20-year-old person just remembers hearing about it when they were 5 or 6 and people were telling them. So first-hand experiences start to be more culturally relevant. Like it could still be a boring story, but just kind of having everybody's story becomes part of the historical record. And I was thinking it might be part of the Hythloday principle to go through a little bit of 9/11, because I was definitely paying just as much attention as now. Very political. Saw a lot of weird stuff happen. Supported certain things. Didn't support other things. Supported things that, well, anyway, I'll get into it tomorrow. But not necessarily supporting things, but deciding what to oppose and what to go, okay, fair enough. And then even the things that I said, okay, fair enough, I won't oppose that, should have been opposed and I knew better and whatnot. But also just that day, and just, it's definitely one of those assassination of JFK things, like where you remember where you were and what was going on and how you found out. So, I will leave it at that, and thank you very much for being a part of this. This is Apiro 314 broadcasting from the, let's see, MCW CAM broadcasting platform, or via the platform. I myself am not in the stratosphere at the moment. Soon, we're working on that. All right, happy fall, everybody. I think fall has begun. We're going to have some nice fall weather, but let's just face it, fall has begun. Going to have to take boats out of the water, um, get your generators tuned up, and get ready to be walking on the water in a very short period of time. It's that long stretch. Winter is coming. That's what I'm saying. Winter is coming. You know it's coming. Don't call me a liar. So how long was that? Probably 20 minutes. Okay. Cheers.